This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will continue constructing the Plan B variable positive power supply. Part of my standard operating procedure is to use this multi-component tester on each of the components that I'm going to be using. So we start off with C1, 100 microfarad capacitor, which is not quite 100. The second one for the second board, about the same. C2, it should be 1 microfarad. And kind of right. And the second one is right on there. This should be 0.01 microfarads, and it kind of is. Tantalum capacitor, it should be 1. And I'm kind of concerned about these high equivalent static resistances on tantalum capacitors. I'm looking at every one of these things I have. Here's a 0.01 capacitor, 0.01 microfarads. Connected right, okay. Another 0.01. Right. Point 1. Okay. It's a C6. And I had this at 10 microfarads and really couldn't get a dependable 10 microfarad capacitor, so I'm using 22 microfarads, which comes out to be a little over 22. Good enough. It's an output capacitor. It's no real serious problem to have a larger one. There's my load resistor. Should be 1K, and kind of is. And there's the second load resistor at 1K, and that's fine. Now I've got diodes, and these are old diodes, glass bead diodes that aren't marked, which is probably how I got them. Rejects, I guess. And I'm using this component tester to tell me what's the anode and cathode of these. Marking the cathode. These are supposed to be 2 amp at 50 volts. Continuing to test and mark some diodes. There are 6 diodes in total required, 3 for each board. Reverse current of 93 nanoamps. Okay, I'll put up with that. Now, I've been debating how much of this stuff I should include in these videos, because this is just cutting a bunch of wires to size. Actually, the size is bigger than I think we're ever going to need, which of course is going to turn out smaller. It is dreadfully dull and boring. However, my objective here is not to entertain. This is an accurate log of what I was doing last week, and you're kind of stuck with it, regardless of how boring. I'm trying to maintain the same color codes as various binding posts in previous diagrams. These wires are in general number 18. Once I got all these wires cut, I now need to strip both ends. Not quite as easy as it looks. If I misalign the wire with the cutting edge, I'm going to cut the wire, which is not what I want. Although in this particular case, the lengths of the wire are not that critical. This is so much easier than using a manual wire stripper. There are different thicknesses of insulation. I should try to be consistent, but the wires I have are the accumulation of purchased stuff and confiscated, repurposed stuff like this. That does not look like number 18, probably a smaller gauge. It's an old hi-fi system speaker wire for a really cheap system, I guess. Couldn't afford the extra copper. But for my purposes, I'm using relatively short lengths of this. We're looking at the maximum length that I would use. And it's going to wind up, I think, considerably shorter. I just don't want to have to extend these wires later with various and sundry unnecessary soldering operations. Maybe there's a better wire stripper, I don't know. Now I've got to start drilling holes for components that require larger than the standard holes, and the first set of holes I need to drill are for the integrated circuit. The LT3080. Five holes. Using number 55 drill here. I cheated, I measured ahead of time. These leads on this IC are actually a lot easier to bend than I thought they might be. It's a matter of not being too aggressive. And I have got that IC fitting. It is properly aligned. And of course there is the second board. And once again, the second IC. Gently, gently. As long as we have that back tab sticking out far enough to be bolted to the enclosure panel. Now I'm going to start placing the components on the boards. Make sure their polarities are correct. I have to be particularly concerned with electrolytic capacitors and diodes. Wonder if they make a reasonably sized 1 microfarad non-polar capacitor. Get rid of these tantalum things. There is one jumper here, and that jumper is just connecting two sides of negative connection ground. Ground in the sense that it's negative. Now these diodes, I just hope they're correctly wired or they will cause no end of problems. Some more exploding diode theatrics. Now, these capacitors are a lot smaller than the ones I've used before, and they're cheaper, and I hope they're not going to explode. I'm kind of shell-shocked. The leads on these diodes are just about thin enough to fit through the standard holes of the strip board. $1K, 1 watt. This is the second board, and before you start sticking components in, it's a good idea to clean things up. Drilling the mounting holes here. In this video, I continued construction of the Plan B variable positive power supply. I tested each of the components for the two boards. I cut and stripped a set of hookup wires for the two boards. I drilled holes in the boards where larger than standard strip board holes were needed and placed the components. In the next video, we will complete the construction and test the Plan B variable positive power supply. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.